That's from your book, Crude Oil, page number 268. What are our objectives for today's lesson? Um, we should be able to, number one, let me pick up a nice pen. Okay, to know that crude oil is a mixture of hydrocarbons. Describe how the industrial process of fractional distillation separates crude oil into fractions. Very, very important, this area. Okay, this one is very, very important, this part. Okay, know the names and uses of the main fractions. This is also very important, but you have to memorize this part. Okay, and along with that, refinery gases, gasoline, kerosene, diesel, fuel oil, and bitumen. First of all, you need to be memorizing the names and then their uses. They're having solid marks. Know the trend in color, boiling point, and viscosity. Main properties are there for it. Know that a fuel is a substance that when burned releases heat energy. What is a fuel? The definition of a fuel. Anything when you burn and it releases energy is called fuel. What is the best fuel? The best fuel is the one which is releasing a maximum amount of energy, which releases less carbon dioxide, which is eco-friendly, which is used in less quantity, but more and more of the energy is being given out. And know the possible products of complete and incomplete combustion of hydrocarbons already done, and we talked about carbon dioxide, we talked about carbon monoxide and their effects. Know that, okay, we didn't talk about carbon monoxide effects. So carbon monoxide is highly poisonous in nature. It cuts down the supply of oxygen to the blood, okay, and it makes the blood carboxyhemoglobin. From oxyhemoglobin, it makes it carboxyhemoglobin, which is incapable of carrying oxygen to different parts of your body. So first of all, it causes suffocation, and then after that, certain death. Okay, know that in car engines, the temperature reaches is high enough to allow nitrogen oxygen from air to react, forming oxides of nitrogen. So around the temperature is 600 to 700 degrees of Celsius. So we can get nitrogen monoxide, nitrogen dioxide, dinitrogen tetroxide, and several kinds of other oxides we can get. So nitrogen can only react at 600 to 700 degrees Celsius in your cars. Explain how the combustion of some impurities in hydrocarbon fuel results in the formation of sulfur dioxide. So if sulfur quantity is there in the fuel which your car is burning, so definitely it will release in forming sulfur dioxide, and ultimately sulfur dioxide will change into trioxide, and then it will cause the acid rain. Okay. Describe how long chain alkanes are converted into alkanes and shorter. Okay. So we are going to study two main important things here in this chapter. Number one, we are going to study the fractional distillation process, this one. Okay. And number two, very, very important one, and that is the refining and reforming, or we can, this one is actually called cracking. Okay. Refining is another step. So cracking will be used. Okay, and what is cracking? The examiner will ask you what is cracking, first of all, what are the conditions for it, and secondly, what are the products of cracking. So when you take large alkanes, that's the definition. Large alkanes are broken down into smaller alkanes and alkenes. This is called cracking. And what are the conditions for cracking? The conditions are using silica or alumina, which is aluminum oxide, Al2O3, as a catalyst, and the temperature is from 600 to 700 degrees of Celsius. Keep this in your mind. Okay, so we are breaking down and repeating once again larger alkanes into alkanes, smaller ones, and alkenes, smaller ones. We'll talk about this in detail. Explain how cracking is necessary in terms of balance between supply and demand for different fractions. So this question is also for 2 marks. This question is for 4 marks. Okay, 4 by 4 you can get it. 2 by 2 you can get it. And this question is really, really a bigger one. You can get around 10 marks out of it, okay? You have any question? Okay, now I'm moving towards the fraction distillation, okay? This is the fractionating column or fractionating chamber will be provided to you. Keep this in your mind, okay? Either the picture will be provided to you and you will be asked to label with different fractions, so you have to memorize it. Keep this in your mind. So first of all, let us talk about what is fractional distillation. What is fractional distillation? I need to know.
Sir, the separation of a mixture.
Okay. So what?
Separation of.
Fractional distillation is based on the boiling point. Number one. Number two, if you have two miscible substances mixed together or many miscible substances, by miscible we mean to say which have a little difference in their density, okay, which can be completely mixed up. You have already studied when you add alcohol and water. So these two are miscible substances. Alcohol is having 78 degrees of Celsius temperature and water is having 100 degrees Celsius. These are both the boiling points. When we heat up both of them in a closed container, first of all, the alcohol is going to be eliminated out and we can collect it. And then the water is left behind. The same process applied here. Okay? Now we'll take the crude oil in this chamber. Are you with me?
Yes, sir.
Okay. Yes, sir. We will take the crude oil in this chamber, and the chamber is something like a big, tall chamber. Okay, it can be 60-meter high. This one, cylindrical. We insert the crude oil here in the heater. Okay, we heat up the crude oil, and now you can see there's a range of temperature here. The high temperature is here 400 degrees Celsius and it's leading to 40 degrees Celsius at the top. Heavy fractions. By heavy fraction I mean to say more carbons in the chain. Okay? More carbons in the chain. Like if there are alkanes, more carbon in the chain. So when we heat up, the heavy fractions stay here and the light fractions are going up and up and up. So we get the fraction based on their boiling points. The one that is having a very low boiling point, it will rise up till here and it will start condensing on this point. And then we are going to separate it. So you can see the gasoline condensing is there. And if I just decrease the size a little bit, we are still having more. The refinery gases are at the top. So you can see refinery gases are to be collected here on this point. So first refinery gas is at the top. Then the gasoline, then kerosene, then diesel oil, then fuel oil, and then we collect bitumen. Right? It's all based on boiling point. Low boiling points are here and high boiling points are here at the bottom. So you take the crude oil, you heat it and you put it in this fractionating column and you get everything to be collected at the end. Right? Separately. You might have seen there is, when you go to the petrol pump, there is special 98 and special 95. One is green, the other is blue. right? So they are all fractions. So these fractions are separated in this particular way. Okay, are we clear? This diagram is very, very important. Keep this in your mind. They can either give you the diagram and they'll ask you to label these parts. Some blocks will be given here like this, and you're going to put these names in it. At the top should be refinery gases, at the end should be vitamin, fuel, then diesel oil, kerosene, and gasoline. Right? This column is called the fractionating column or fractionating chamber. Do you have any question?
No, sir.
No, sir.
Okay, now let us move forward and we will see the uses of different fractions. So if you see your book, you will find different uses are given there. And those uses are, see this now, starting from this area. Combustion we have already discussed, okay, this we already discussed. So where do we use the refinery gases? First of all, where are the refinery gases being used? It is containing methane. It's a mixture actually of methane, ethane, propane. Okay, so these, and even butane is there in it. Now the gas cylinder which is provided to your homes, they are full of methane and we are using that in our kitchens. These gases are commonly used liquid petroleum gases or LPG for domestic heating and cooking purposes. Okay, keep this in your mind. So whatever in your kitchen is being cooked out, actually it's because of these gases which you're using right now, and it is supplied nowadays into every building also. Okay, clear?
Yes, sir.
Yes,
Okay.
yes, sir.
Now moving on to the second part, the gasoline. Now, if we look into gasoline, as with all other fractions, petrol is a mixture of hydrocarbons with similar boiling points, and it is used as a fuel in car. Gasoline, which is petrol, is used in fuel in cars. Okay, so this is the use of it. You need to know the name, you need to know the use. 1 mark and 1 mark. Okay, 2 marks and 2 marks. One for the name, one for the use. Moving on to the kerosene. Kerosene is a little bit heavier than petrol, so that's why to take a heavy duty out of that, we are using this in the aeroplanes for the aviation fuel. Okay,
Yes, sir.
and we can use it as paraffin also. One of the fraction is paraffin to lit up the heaters and lamps also. Now, the next fraction is the diesel. Now, the more loaded work you want to do with the engines and machinery, the more powerful fuel you need to be using for it. Okay, so this one is used basically to run the most powerful things, like for example, the rail engines, some cars and tractors, and big lorries, and the big buses. Okay, so they are basically using, they're very powerful, and trains usually when they're mounting up at that areas, this powerful oil is used. Okay, because it's releasing a huge amount of energy. Along with the huge amount of energy, a huge smoke is also being released out. And the reason for that is because it's having many more carbon connections in it. Okay?
Yes.
Okay, moving on to fuel oil. Now, much more powerful work is to be done, and a huge amount of energy is needed. Now, you can see the huge container here. So, we are using these for the industrial process class. हाँ, पता नहीं है. Okay, so it is used as a fuel for ships and industrial heating. So these big ships, they're run by this fuel oil, which is having more carbons in the chain. They're having high boiling point, so they are at the bottom of the fractionating column. Now, what is left is the bitumen. Bitumen is a black liquid which nowadays they're using, and before also, it is being used to sprinkle on the road, mixed up with the gravel and sand, and to make the road construction. Okay, so you might have seen black color of the roads are there. So this is because of this bitumen. Keep this in your mind. It's a viscous, very viscous one. If you see there's a road construction going on there, you will see that they're spreading some black liquid on it. Okay, so bitumen is a thick black material which is melted and mixed with small pieces of rocks, make the top surface of the roads. Are we clear?
Yes.
Yes, sir.
Yes, sir.
Okay. What are the environmental factors and problems associated with the burning of the fossil fuels from the crude oil? The most important thing is that they're releasing carbon dioxide. That's the most important part of it, of this discussion. And carbon dioxide is basically a greenhouse gas. And the effect of the greenhouse, we have already discussed that the sunlight is being trapped in the atmosphere and it's unable to release out from there. It's just like your car is standing in the sun for a longer period of time. The windows are closed, and when you go from here right now, you have to open the windows, and there's a huge difference of heat energy between the outside and the inside of your car. So then you turn on your AC, and then the things are quite controlled now, right? So the same is happening with our environment, our Earth. So when the sunlight is falling, it's crossing the atmospheric threshold. Actually, it's coming to the Earth. If this is the Earth, okay, when it's going back, it cannot penetrate from here, so it rebounces, and it goes and it rebounces. It goes and it rebounces. This is the greenhouse factor. It is releasing, increasing the temperature day by day, which is bringing the climatic change. Natural calamities happens. The earthquakes and the other volcanic actions, and most of the time, you know, the climatic change is like it's not rainy, but it start raining all of a sudden, and flooding, the sea level rise, and all this stuff is related to the environmental factors.